So hello everyone, in this video we will be talking about a new algorithm. So as you can see, it is basically a classification algorithm and we will use the Bayes theorem given by naive Bayes. So we will use that theorem to do something, and we will just try to predict that what class do our given data belong to. So let us just start. So this Bayes theorem uh, have been have been explained in my mathematics for machine learning video, so you can go and check it out there. And also of course you should have learned this in your high school, so in your class 12 basically. So so probability, this shows that the probability of y given x is equals to the probability of y intersection x divided by probability of x. So what is the probability of occurrence of y when x has already occurred? So both should have occurred divided by only x. Okay, so this is the essence for Bayes theorem, where p given x is the probability of the occurrence of an event y when an event x has already occurred. And you also know that p a given b equals to p a intersection b equals to p a b into p b, and this can also be written as this p b a into p of a. So this directly follows with cross multiplication of this equation, and we can then write probability of a given b is equals to probability p given a into probability of a divided by probability of b. So this result of Bayes theorem we will use to help us build a classifier model. So let us just see how can probability exactly helps us in classification things. We saw about the logistic regression and stuff, but how can probability help us to build a classifier model? So let us just first try to get the essence of that. So suppose we give an input x to our ML model, then what would happen? In case of classification, suppose we have three classes, then an output y will be given by, suppose the classes are a, b and c. In case of iris data set, it is iris, setosa, virginica and versicolor. So assume there are three classes, so y would give three outputs, any one of the three outputs, given that an input is x. Now we can think of applying conditional probability as being probability y equals to a given that the input is x equals to small x, or probability of y equals to b given that we have an corresponding input. So we can calculate these kinds of probability. We can think of calculation of these probability with Bayes theorem, because that looks similar, and the maximum value of these three probabilities would give us the desired result for particular x. So our prediction of our ML model will be a single class, right? We can't predict this all the classes are this way, so we have to predict a single class, and that single class will be given by the maximum probability which we will obtain out of these three. So now we will generalize these things. So for general case, where x has multiple features and y has multiple classes, so what was capital X? Basically an input, and you know that input can have multiple features. A particular input can have multiple features x, and y has maybe multiple classes, three classes we discussed. So let us assume that they have multiple classes. So give probability of occurrence of y of a particular event cj, let's say that class cj, given that x equals to xi. So what is this I? This I is basically the row value. Suppose there are n rows, then I will iterate from 1 to n. So one row gives the value of a particular value of x, then that x is known as the xi. Okay, and we have just interchanged this. We have used the final results of that Bayes theorem. Now we need the maximum value out of all the classes, right? We have classified the as I shown that in case of three classes, what will be the maximum probability? That will be our answer. So we need to calculate all those probabilities, and we can just calculate the maximum value of this. So we need to tell that basically for what value of j this probability will be maximum. So if you see, for as we are iterating j, I is constant. Can you understand this? For one row, I is constant. For a single row, if we fix the row, our I becomes constant. But if we fix the row, our j is not becoming constant, because the still our output can be multiple classes. So this denominator is constant, and if we want to find the maximum value of this, it is sufficient to find the maximum value of only the numerator portion. Okay, so we are calling it some probability p dash. So this is not exactly a probability, but just to maximize the thing, we are just doing this. Okay, so now there is a naive assumption: the features of a dataset are independent. Now this naive Bayes classifier is particularly useful when the features of the dataset are independent, and that should be the case also. I have explained you about the correlation matrix in my videos of principal component analysis and all. I have explained you about those correlation matrix and stuff, and I've also explained that we can sometimes ignore one entire column of feature just because it is too much related to the other features. We can simply ignore that. So these features of the data set should be independent, and it takes that ideally they are not at all related. So this is the naive assumption. So now we know that probability when given data set are independent, we can simply multiply now. So what we do, we have multiple features, right? So you see, xi is for a particular row, but for one row, not only j can vary, the x can also vary because they have multiple features, right? So in this superscript 1, 2, 3, as you can see, they are the multiple features, and we are assuming the features to be independent. So for each row, we can just multiply all the features of those probability. Okay, so don't get confused by the notation. I have explained clearly what is I, what is j, and what is the superscript. So here xi of 1 denotes the value of the first feature of the ith data point. Okay, and this n is of course the nth feature. So the superscript is corresponding to the feature, and the features are independent. That's why we are multiplying. After taking up the naive assumption, we can easily calculate the individual probabilities, and then by simply multiplying the result, we can just calculate the final probability, right? So we aren't bothered about that denominator I told you. So this p dash can be calculated by simply multiplying y of cj, probability of y of cj. So finding the second term in the above formula is pretty straightforward. You can just suppose you are given to find the probability of a particular class. So what you will do, you will simply divide the number of observation of that class divided by total number of observations. So that's really easy, right? So let us see the first term. Okay, so let's just have a look. That's also quite simple. So first term was this. It can be written as count of training data, where x equals to xj. This j is the jth feature, right? I told you superscript represents the feature, and y equals to c. So the count of the divided by the count of the training data, y equals to c. So let us take an example and understand. Suppose this column represents what is the salary of an employee working at a particular corporate, and in that company what is the workload. So basically the workload is high. You can just take that yes means the workload being too much, and no means the workload being not that much. Okay, so I suppose I ask you what is the probability of the salary being high given that the workload is no. So what would you do? You will say count. So this is a similar thing, right? You will say the count of the training data, this and this. So first you will say what is the count that salary is high and load is no. You see load is no as well as salary high. There is only one count, that is the last row. That's the count of the training data. The entire numerator becomes 1, and the count of the training data y equals to c, load equals to no. There are only 4 observations, so 1 by 4 probability. So that's also quite simple. So this way we can you just have a look at the previous slide. This way we can calculate both the first term and the second term, and we can just multiply. So we can use easily we can use a loop like to iterate through these, and we can just multiply while at the same time calculating. So now there is a thing called Laplace correction. So you need to understand this concept. We are what we are doing here, basically we are multiplying probabilities. We are here multiplying probabilities. Now suppose, what is the example of a classifier? In the first logistic regression videos and all, I have clearly explained you what are classification algorithms basically. So they are about predicting something, some classes. Suppose now a very common example is detecting whether an email is spam or not. So that's also would be a classification algorithm. Now suppose you find a new email and feed it to your machine learning model. Now suppose the model is trained with a lot of training data, but still in your new model, in your new mail, a word is there which the model did not see earlier. So what is the probability of occurrence of that word? 0. So if one term becomes 0, all the other terms become 0, and our model will always give the answer of 0. So that's some error which we need to take care of, right? This probability can be 0, and our ML model may see a new word in our new mail, but that doesn't mean it would predict anything, right? There may be other similar words which it has seen earlier, and it can easily detect whether it is spam or not. So the probability, we can't let it be 0 easily. So we have to do something regarding this. So that's basically is handled by Laplace correction. This is done to handle the 0 probability. This email spam case I described it just now. So it's just a convention that probability of x given xj equals to y given that y equals to ai. So we will basically do the same thing, and the count of y ai, we will just add one and add the number of possible values that x can take, right? That is all the features, the superscript x I was talking about. There were n of them, so if there are n features, the capital N of x will be simply n. So why it is done? So let me explain you with that email concept. Now what we do, we say that even if our ML model did not encounter a new word in our mail and did not find that word earlier, it will pretend that it has seen it once. Okay, so it will just pretend that it has seen it once, and then divided by the total number of features. Basically, out of all the features, that is out of all the words, it will pretend that it has seen the unknown word at least once. So that really takes care of our 0 probability. So that's the essence behind this, and the next video we will talk about the how exact application of these Laplace transformation using our very Python libraries and all. So it will be much more clearer, and next video we are going to do the project of text classification. So basically we will just feed a document in our ML model, and it will predict what is the concept being discussed, what is the prime concept, or what is the prime topic being discussed in that document. So that's basically a text classifier. So we will see how to create that project. So this is just an example. You can see with Laplace correction here, outlook. So suppose you are given to find that outlook is rain given that no play. Outlook is rain given that there is no play. So you can see play no is at 4 places. Outlook is rain given that there is no play. There are only 2 of them. So we'll just write 2 plus 1. This is the Laplace correction, divided by 5. Outlook is rain, so how many, just you can uh, just a second, what was in the denominator? Well, the denominator was count of a y of ai, so count of this given condition. So if it is no play, the count of this given condition should be 4, right? 4, and this n is basically this possible values that x can take, that is x is all the features. So what are the features that Outlook can take? It can take sunny, rain or overcast. So there are 3 features, right? So it will be just 3 by 7 instead of 3 by 8. Just make a correction here. Instead of 5 plus 3, it will be 4 plus 3. So 3 by 7 would be the answer. So basically I may have missed one more row in which it was no written over that, and maybe this was no itself. So whatever be the case, it would be 4 plus 3 equals to 7. So with Laplace correction, 1 plus 1 and plus 3 is being added. So using sklearn, there are like to implement naive Bayes classifier. So these were categorical data, right? This belongs to this particular category, and but for continuous, we may have a continuous data like the iris data set. So that also we can handle by dividing in particular categories. So that you can directly do with sklearn. You can just import naive Bayes like this, and then you have option of naive Bayes dot creating object handle like this, categorical NB. There are Gaussian naive Bayes, there is multinomial naive Bayes. So you can just keep fitting and see which gives the best accuracy to your model. Okay, so that's all from this video. In the next video we will talk about a project on text classifier. Till then, thanks a lot.